Hi folks, welcome to my Bit Retro Journal. What I'm working on today is a compiler for my ZX81 Timexing Clear 1000. I did back in February, I did a video on compilers for the QL, and so I wanted to address compilers for the ZX81, and there is one. It's called MCODER2. It's a pretty neat application, so I wanted to demonstrate it. So you actually have it up and running here, and basically you load it from tape, and when you have it up, you then load the next program. So this puts itself in safe memory, and then you load the next program and then run a few USR commands. First one to merge the program with the BASIC, and the next one to compile it, and then you can run it. And so I wanted to, and it has a pretty decent manual. It's got like 4 pages of this. I couldn't get everything to work, so I'm not quite sure what's going on, but I got a few programs to work, so I just want to demonstrate that to you today. And so what I'm going to do is I'm actually going to set the camera up so that it's facing in front of the Timexing Clear 1000 so that you can have a better view of it. Okay, so let me do that. So this is a pretty nice picture. And so what I want to do is load in the first program to test. And so the first one I was going to do is my banner program. And so basically you have to load it, and then once you've loaded it, you can run it or you can compile it. So let me see. I have to load it in from, again, my desktop computer via audio. And let me find it. So this is going to be the banner program, and I'll show you what that looks like. And what we want to do now is we're just going to go load. Here we go, load. This is in fast mode. And so I'm going to hit return, and then I'm going to skip over the load process, and so I'll come back when it's loaded. All right, here we go. All right. We are back, and so now I have the program loaded, and if you take a look at it, it's my banner program. So if I run it, you can see that it's running its usual slow pace, but takes its sweet time. And what I want to show you is how much faster it can run once I compile it with the MCODER compiler. All right, so let me do that next. So I'm going to break out of this one, and so this is where, yeah, and it'll do both the spiral and the, and again, the ZX simulator on my QL actually works at a similar rate. Let's wait till it does a spiral one, but this is maybe slightly slower. It really depends on what operations it does. It's at times faster and at times slower. So now it's going to do the spiral pattern. So there's just a little test program I wrote. Yeah, so you can see here comes the spiral pattern. So I want to show you how much faster this is once we compile it. All right, so I'm going to break it, and then what you do is you basically type in let L equals. And then it's 32462, and that will attach the compiler program to the basic program, and then you're going to compile it. So you're going to say let L equal 17,300, and that actually is going to compile it. And you can see this is just going to shoot the program out. And yep, now it's compiled, and you can run it. So I'm just going to hit yes. So you can then save this as well. This is just basically it has the compiled program as part of the basic program, and you can remove the basic program if you want. So let me do that. I'm going to hit yes, and again, watch how much faster this is. I mean, that's a whole heck of a lot faster. It's just zipping right through. Look at that. So that's pretty impressive. There's things it's supposed to be able to do that it's not able to. For instance, I have a bunch of programs that I wanted to convert, and supposedly it can do Go subs, but I have not been able to do Go subs. Now, I don't know why. I have another program. So the next one I'm going to show you is my bouncing ball program, which I had to modify, and I've used that also for the ZX simulator. But you can see this is just fast. Definitely three or four times faster. I mean, this is just zooming right through. So that's really nice. Unfortunately, you can't. There's no way to. It's supposed to be able to break it, and I haven't figured out yet how to do that. So there's some things in the manual that it says it can do, and I haven't seen this yet. So let me reload the basic compiler, and then I'll load this one back. All right, so I'll be back. All right, well, I'm back, and this time I have my ball program running, and you can see I actually had to modify it. So in the past, I would have it where you can see the prints. It would actually do a go sub call, so you can see all these are repeated. It just couldn't figure out how to do go sub, so I just copied the routine that draws the ball. So let me just show you how this runs, and enter start. And yeah, so it has a little bouncing ball that goes all over the screen, and it's a little faster now because it only does it. It doesn't have any speed function where you could actually slow it down. So this is the fastest one, and because it's not doing a go sub, it's slightly faster than it would have been otherwise. But so it zooms up and down and all over the place on the screen, which is pretty cool. But yeah, it doesn't have the functionality of reading the in key and speeding it up and slowing it down. Again, I need to figure out what's going on with regard to why go subs don't work, because in the document that I have here, which right here, it literally states that go subs should work as is in a normal basic program, but for whatever reason I can't get it to work. So I thought maybe I didn't have a proper return. Now my go subs all are within a for loop, so maybe it can't do that. But I've tried various programs, even the Dragon program I have. So anyway, let me now. I'm going to compile it, and again, the way you do that is you're going to say let L equals, and you can see this is in real time. The compiler actually works pretty well. So first, this is the user routine to attach the compiler to the basic program. So if I were to list it, you can see that at the very top, let's see, can we do so list one? Yeah, so that's you can see now what you have at the very top. The rem statement is the compiler, MCODER2, that's then tied to the basic program, and my basic program starts at the bouncing ball right there, right? So this is the two mergings of the two, and so now what I can do is I can compile it, and I'm going to run again. So it's just using the let L equals user, and then you have the different addresses. So this is going to do the compile. Here we go. And it just sort of lists each line as it takes it. And I think it goes through it twice. Yeah, and the second time around. And it's going to ask, do I want to run it? And I'm going to say yes. There we go. Enter. So it used to have speed here, so I'm just going to enter to start. And you can see it's a little faster. So nicely compiled. And now, unfortunately, I cannot break. So the space key does not break it, and neither does supposedly shift edit. But that is not working, so I don't know what. I'm going to try all sorts of keys, but I haven't been able to figure out why this doesn't break. So there's a whole slew of things in this documentation that seem to not be accurate. But the fact that it can compile and run code faster is actually pretty remarkable. Let me get back to this program, compile it, and I want to do another call here. So I'll do this with the oh, maybe I'll do the banner program again, because there's supposed to be a way to remove the basic code, and I haven't figured out how to do that yet. So let me try that again. All right, so I'm gonna come back after reloading everything, because it takes a while through audio, and I can't use OTLA's fast load because I think OTLA and the machine code loader would be occupying the same space. I haven't tried that yet. Maybe I'll try that at one point. Here we go. So I decided to just redo the ball program, and you can see here that if you do you can do an let L equals USR 2500, and it'll actually run the program. And if I say no, now I can actually list the program. So list 1, list 10, and there's the program, and above it is the, so that's the machine code program right above it. Well, there's 3, and then there's, I think it's 2, and then 0, and then so what you're supposed to do, and this time you can actually do where is it, rand user, and if you go let me check the manual again. It was 17, I believe it's 17281, and you can supposedly, I want to give it a try. So 17281, I think, is what it's supposed to do. And what it does, it just goes haywire. Yeah, I don't know what's going on there. So just kind of goes crazy. So don't know. All right, so let me get back to the final program I want to run is going to be Noel's test time-wise. So let's do that. So we're back, and if you take a look at it, this is just a simple little timing program, but this is going to take quite a long time. So what I'm going to do is I'm going to start a timer and see how long this takes to run, and then I'm going to run it in the compiled mode. So let me start the timer. See where I'm going to start it here in 5 seconds. I'm just going to hit run, and here we go. Go. And yeah, so I will so what it's going to do, it's going to print a dot on the screen eventually, and what I will do is I will come back to it, because this is just going to get too it's going to take a long time, I assume, but and then I'll compile it. We'll compile it and run it and see how much faster it runs then. This is a test program that Noel from Noel's Retro Lab ran to compare a bunch of different computers and their speed. So there's one, but it has to print 10 of those dots. So I will come, can you see the dot? It's right there. So I will come back as soon as it finishes running. Okay, here we go. All right, so it took about 4 minutes and 40 seconds to complete this task. And again, it's a simple basic program that just has an outer for loop 1 to 10 and an inner for loop that goes from 1 to 1,000. So basically this is running 10,000 times, and it's just summing up each inner loop to the outer loop. So yeah, 4 minutes and 40 seconds. So let's compile it. So again, we're going to go let L equal user. So first I got to tie in the program so that you can see at the very top, list 10. And then if you go upwards, you can see that, I guess you got to go to list 1. Yeah, so that's the compiler, and then you're going to run it. Let L user, oops, wow, fat fingers, and it's 17,300, and we're going to hit yes, and so it's going to do the compile very quick. And so now we're going to run it, and again, I'm going to open up a timer on my Windows machine. So here we go. I'm going to say yes. And it was, oh, well, the value is wrong, but it did it all in like 5 seconds. Interesting. Why was the so don't really understand why. Oh, yeah, okay. So it took like 5 seconds. The problem is the number was too big. I think integers can't get bigger than 32,678. So, or 15 bits, I guess. So that was the issue. But certainly, it did the loops. It just wrapped the number wrapped when it became bigger than that. But still, that's a huge speed gain for a simple, fast loop like that. And so it's a terrific little compiler. The user manual for the MCODER2 is pretty comprehensive. Gives you sort of a rundown on how to use it. It has a list of functions that are legal, and you can see it's pretty vast. And the one thing I haven't figured out is GoSub doesn't seem to work for what I'm trying to do. But it says here that it's legal as long as you use line numbers, not variables. So I don't understand why I can't get it to work, but that's been one of the major problems. It has a way to relocate the code. For what purpose, I'm not 100% sure. And then the specific error that we just got is that you should be allowed to delete code quickly using this rand user 17281, which I tried and it didn't work. And then there is a more formatted manual by Timothy Swenson, and it has the same stuff. If you go to the very end, it'll show you the cheat sheet, which is to attach the MCODER to your program, compile it. Again, here, delete code, relocate code. Right, you can use normal behavior of rand and stop, but there's also 2050 is the one you use to run. I found it's up here, right? So you can add this to your basic, and that'll run the machine code version of it. So and then it gives you a nice list of most common ones. You can do string slicing, but not with the left out values. But all in all, it's a good document. I wish it worked the way it's advertised. So I still don't understand. And even it looks like it has a max int of 32,767. But still would like to understand why it does not work for some of these things like GoSubs. The only thing I can think of is that I have my GoSubs in a for loop, and so it's calling it repeatedly. But that should work. I mean, there's nothing illegal about that. So if anyone has played with MCODER and knows, it'd be interesting to understand why. So yeah, it's a pretty neat compiler. I don't know what state it's in now, but I was trying to, it's not responding, so it doesn't do well after the compile, but anyway, pretty neat compiler that really helps you speed up some programs. What I wanted to compile on there is my elite program because it's kind of slow. But again, I mean, it has a list of commands that it's supposed to say as basic and GoSub. It says calls line n as a subroutine. If line n does not exist, then it goes to the next line after n. Note that n must be a positive integer constant. And for returns, it just says returns from the subroutine started by GoSub. Make sure that your GoSub and returns match as no check is made. Well, they all match, so I don't understand. It does say here that returns can be used to end a program, but I assume if they're matched up. So I got to explore a bit more. This is the first time I've used MCODER. It's just the load times on, I can't use the OTL loader, so the load times are just take a long time to load, and it's not always the quickest. So I also played around with it on the 81 emulator, but I wanted to do it on the actual ZX81. All right, so I will end here today. Thanks for joining me, and I'll see you next time.